Assalamu alaikum. Welcome to what we are calling the first tutorial of this semester. As I told you, this will be a place where we will solve all questions of quiz 1 and quiz 2 of both the sections together, sort of as a preparation for the midterm. We will start from quiz 1, of course. So we are calling it question 1A. We could call it any name. The multiple choice part of the quizzes. And remember, there were many questions. They were shuffled, so everybody does not get the same questions. And here we will go through only a few of them, not all of the possible multiple choice questions, of course. Materials that produce electric field when exposed to mechanical force or exhibit mechanical stress when subjected to electricity are called what? Piezoelectric materials, shape memory alloys, nanomaterials, electronic materials. So, of course, if you know it rightly, the answer is piezoelectric materials. These are materials where if you send in electricity, it will change the mechanical stresses and so on. Let's go to the next one. What I would like you to do is that again, you see at every question you can pause, right? So don't listen to my answer. Pause it for a second or two. Try to think of your correct answer and then proceed. That way it would be better as a practice. New processing techniques to improve product life and fatigue properties are which one? Isothermal forging, IF, powder metallurgy, PM, die casting, DC, or both of these. IF and PM means isothermal forging and powder metallurgy. So if you remember this part of the first chapter, then both these techniques, isothermal forging and powder metallurgy, are very good to produce things which have long life and good fatigue properties. Next one. Fullerene and graphene are types of what? Nanomaterials, electronic materials, biomaterials, composite materials. So again, right, both fullerene and graphene are the major types. There are some other major types of nanomaterials. Most abundant metal in the Earth's crust is what? Silicon, iron, aluminum, sodium. So we discussed it in quite some detail. We gave you examples of iron and aluminum transformation also. But the biggest amount of metal in the Earth's solid crust is silicon. Most important material property for high-speed civil transport is what? Temperature resistance, impact strength, hardness, all of the above. So first of all, remember, high-speed civil transport means a very large aeroplane with hundreds of seats in it, passenger plane, which is traveling at supersonic speeds. So if that is the case, then all these are important, but the most important will be fighting the high temperature rise because of the air friction. So temperature resistance will be your answer here. Now this is what I'm calling question 1B, because now we will go to the true-false questions. And again, remember that we are doing only a few samples here. We cannot cover all of the ones that were there. Smart materials change their properties when exposed to specific temperature, stress, light, humidity, etc. What do you think? Is this true or is it false? The answer, of course, is yes, this is true, because that is why they are called smart. That if certain conditions change, then these materials are trained to change their own properties, so they are smart like human beings in this way. Shape memory alloys and piezoelectric materials are special types of composites. What is your answer? True or false? This is of course false, because right, shape memory alloys and piezoelectric materials, remember, are not composites. They are what? We just mentioned them previously. They are smart materials. Fiber reinforced plastics are a type of high strength polymer blend. Fiber reinforced plastics are a type of high strength polymer blend. Yes or no? This is false. Right? So fiber reinforced plastics are composites. Fiber reinforced plastics are not composites. They are not polymer blends. So therefore, it looks right sometimes, but you have to think a little more. Plastic alloys are blended polymers. What do you think? Yes, it is true. We told you in that place that normally we call them polymer blends or blended polymers. But just like metals, where we mix one and the other thing and it becomes an alloy. So if two polymers are also mixed, they can also be called alloys. So that is also a correct name for the same thing. Nickel-based high-temperature superalloys are modern aerospace materials. Yes or no? Yes, this is true. These are some of the major alloys that are now used in high level of jets and aeroplanes and so on. So this concludes the initial part of the quiz, right? We reviewed some multiple choice questions for you and some true false questions. Of course, remember your midterm is chapters 1, 3 and 6. So a quick reading, you have already gone through the classes, you have already practiced them in the first quiz and second quiz. So a quick reading and then you are ready for it. Let us now go to the other questions. So I am starting with question 2A of section 10. What are smart materials? Briefly describe at least two types. So this was a fairly simple question. Most of the class got it right. Some people who may not have reviewed it quickly, but it is a very simple thing. So here it is. Right, this is right from your slides and so on. Smart materials are materials that change their properties, which could be mechanical, electrical, or appearance, by sensing external stimulus. If there are changes in temperature or stress or light or humidity or electromagnetic fields, right? So these are materials that automatically change their properties if conditions change. So they consist of sensors and actuators. Excuse me. There are two main types. Two main types are shape memory alloys and piezoelectric materials. Shape memory alloys, strained material which has been subjected to strains, reverts back to its original shape above a critical temperature. So there are stresses in the materials, but they are trained that if the temperature changes by a certain amount, then remove these stresses and so on. They are used in heart valves and in stents to expand the arteries. I have explained this earlier. Usually they are nickel, titanium, and copper, zinc, aluminum alloys. Piezoelectric materials produce electric field when exposed to mechanical force, and vice versa, right? That if they are stressed, then they produce. So if electricity goes through them, they show signs of stress. If they are stressed, they produce electricity. They are used to sense and reduce undesirable vibrations. They are used in actuators and vibration reducers, and even in your electric bell in your house. So this was the first part of question 2 for section 10 quiz. Question 2B of section 10. A 0.505 inch diameter aluminum alloy test bar is subjected to a load of 25,000 pounds. If the diameter of the bar is 0.490 inch at this load, determine the engineering stress the engineering strain, the true stress, and the true strain. So once more, my request again that you see, I keep on reminding you all through the classes that if you want any preparation to be good in any course, not in this course, then don't look at the solution. Read the problem, take pencil, paper, start solving it. Maybe you have an access to the formula sheet right now, I mean, right? Because that would be a very good thing. A formula sheet was sent to you. Formula sheet is also on the Moodle. So if you need any formulas, look at the formula sheet. Yes, that will be available. But don't look at my solution. Pause the video right here and again solve it. If you are from section 10, you will be solving it again. If you are from section 20, you will be solving it for the first time. But do that. Don't look at the solution. And exactly this type of a problem has been solved as a class example also. So very quickly, without solving it, let me, we should first write what are the knowns and the unknowns, right? So D0, the initial dia is given, right? Uh, F is the current load, so F is given. Diameter of the bar at this load, so call it DI or DF is given. So initial dia is given, final dia is given, current force is given. Engineering stress. What is the formula of engineering stress? You know, right? F upon A, where F is the force and A is the original cross-sectional dia, original. So if, cross-sectional area. And if original dia is given, then area is pi by 4d square. So you can solve for engineering stress. Engineering strain is delta L by L naught, change in length upon L naught. It is not given. So let us stop it for now. We'll tell you later. True stress. True stress is the force upon the current area. So the force is given. The current dia is this. So pi by 4 d square of this one is the current. So F upon current area. So true stress is known. True strain, remember, is len Li upon L naught type of thing, right? So if that is given or not. So therefore, strains rightly are not there. But then remember that we told you that this will be a constant solution aid, that the volume does not change. Initial volume is equal to the final volume. Initial volume is A naught L naught. It is a cylindrical piece. It is a rod. So A naught L naught is initial volume. AI Li is the final volume. If you equate them, then you can get the rest of the things. So let us proceed. Right. So now all the things are there, right? Area at the start is A naught, pi d naught squared by 4. Area under the current load AI is pi di squared upon 4. It is known. A naught L naught is AI Li. So therefore Li upon L naught is A naught upon AI, right? Engineering stress is F upon A naught, directly there. Engineering strain is delta L upon L naught. So this will Li upon L naught minus 1, right? Li upon L naught minus L naught upon L naught. So Li upon L naught minus 1, and Li upon L naught is A naught upon Ai. So strain will be A naught upon Ai minus 1. A naught you have already found, Ai you have already found, so now engineering strain is directly there. True stress, F upon Ai is already done. True strain is len Li upon L naught. And Li upon L naught, remember, right? Li upon L naught is A naught upon Ai, right? So by doing this, all of this is solved. And again, remember that all of it is already done, right? This is exact. I mean, the values are different, the material may be different, but it was exactly done as one of the example problems. So here we have finished one of the quizzes of one section. We can go to the questions of section 20 or call it section 2, whatever